Right, welcome to this Boxford walkthrough video to take you through Geocam with regard to the scale electric cars. What we've got here is the startup screen from the Boxford software, and I've selected an A3 machine already. We now go into File, Import, and select 3D Geocam. It will bring up a nice little window, always worth maximising it. And then of course we need to select our first STL file that we're going to manufacture, which I will just take the standard body mould. Now then what happens is, because of the way that it was drawn in SitePro Desktop, it arrives on its side. So we need, really just for our own peace of mind stroke help, turn it the right way up so you've got the roof at the top. And then move on. So we're now going to select the cutting plane, and this is where turning it the right way up helps. If you actually look, the cutting plane is blue facing towards us. As we move it round, the yellow means that they're actually looking on the underside. So in reality, if we move that, it actually will be cutting the whole vehicle that way up. So move it. This is why it's worthwhile moving the vehicle into an orientation that you want it to finish in. And we'll work his way around until we're happy. That's cutting edge on with the orientation we're looking at, which that's the way we want to cut the vehicle. We want the roof at the top and the wheels at the bottom. Then we'll actually select where we finish the cut, which, unless you're doing four-sided manufacture, it is generally right down at the base. So you can just type 0 in there, just as easy to slide it down with the slider. So we've now got our model selected, ready to move on to the next steps. Next step is we need to select a material, which a lot depending on what we're machining. We're machining hardwood there. And then tell it the actual physical size of the wood block. We tend to use 150 by 75 by 55 blocks. Now then, I'm actually only going to put 50 in there, because what that will allow me is a 5mm safety area at the bottom that won't be machined, so that I don't need to think. I've effectively given myself a 5mm safety stroke sacrifice board. If you took it to the full 55mm, there is a chance that the machine will go right down to the bed. It may mark the bed, but it would certainly remove the wood in between itself and the clamps, which, as you can appreciate, would be fairly disastrous, because it could flip the wood off before it's finished. So we've selected as block size, and as I say, on the height I've given myself a 5mm safety margin. We'll move on to the actual model size. Now then, you can turn the model round to face different ways inside the block. Sometimes they do come up facing the wrong way, a lot depends how they've been drawn. And so we just spin it until we're happy with the way that it's facing. And then if you notice, the program has automatically moved the block to the largest size that it can manufacture, being restricted by the height. Otherwise some of the edges would have actually disappeared. The trouble is that the block is now, the actual model is now too long. From a point of view of racing, it actually wouldn't fit the chassis. So we need to readjust that back to 100%. Now it does mean that we've got rather thick walls, and if we rotate it, the model will come back up again inside the space that we've left. At 100%, it does mean, as I said, there's a little bit of wastage, but that also means that we can get the machining done without having to miss the sides out. The tool can go down and move out, it can go down, move out. So the next step we do is to alter where the actual model is in the block. You can move the model side to side, front to back. If you had got clamping, such as if we had vices, etc., you may want to actually move the model up to one end so that it's actually away from the vice jaws. On this model, we're actually going to take it down 1mm, and that's purely because sometimes hardwood has a rough surface if it's been rough sawn, and that 1mm does ensure that the roof cleans up properly. So we're leaving it in the middle both other ways. We're just taking it down a little bit in the block, and if you look, we're actually going to miss the bottom of the 50mm block by 5.5mm, so we will end up with a 10.5mm base around the edge. So we know that we're not going to go anywhere near a clamp, so we're not going to damage any of the bracket round the back. Right, so we select the tools. For this particular model, we tend to use the 3.5 radius tool for both roughing and finishing, and at 15 it does give a reasonable finish but will need sanding. 10 takes it down to a better finish, and you can go much lower. When you go much lower, you start getting to finishes that don't need sanding, but correspondingly the machining time's gone up. The 10 represents the amount the tool moves over as a percentage of the cutter width. So a larger cutter would move over more, a smaller cutter moves over less. So you can appreciate that by altering that down to 10%, we have increased the number of cuts that the machine has to make when it's on its finishing cycle. Move on to the next thing, which are allowances. 1mm cutting allowance is generally what we stick to. You can alter it if you've got different tooling, if you're using different roughing tools. And then the next thing is the footprint control, which is really just a matter of making sure that what we're doing is machining all the way around the machine. You can alter these and to actually produce a trenching effect. For our purposes, ticking both boxes will solve it. There's nothing to stop you coming and playing with this later on. One thing about the simulator, it is very accurate. What you see is what you get, so that if you noticed it wasn't machining the sides of those wheels, in real life it wouldn't machine the wheels in the same way with the actual tool. So we'll move on. We'll select raster profiling, partly because it is quite a quick process, and for what we've got here, moving backwards and forwards means that we are working against the clamps, which does ensure that the job is not going to rattle itself free as easily as if we were working end to end against the clamps. And then finally the finishing. Again, we'll leave it on raster profiling, but we have found that 45 degrees does seem to get the best results. It means that you're not encountering either of the sides head on, and it does produce, for these sort of shapes, a better finish. Right, so once we've got to this stage, we've got to actually request the compute, which you'll see the machine's working out its planes for the roughing, and then it goes across and works out its moves for the finishing cuts. You can simulate it, but we won't do for this purpose, because we know that the actual simulation will take place inside the Boxford software. But if you do want to look at your strategies and check things out, you can do quite easily. The last thing we're going to do then is save it. You can save them as two separate files, so that you can do roughing and finishing separately. For our purpose, we're going to save the two together, and I'll call this body mold 3 for no more than it's a free space. And then the Geocam drops away, and we actually get to see the machining simulated inside the Boxford software. If there were going to be any problems, such as tools crashing, it would inform me at this stage, and we'd have to go back to the Geocam and perhaps change the strategy, or look at the tooling to make sure that we've got tooling that can actually make reaches as long as this tool's actually been asked to make. So now go across to the finishing, and the final thing it will do when it's gone all the way across is just clean the base up, which means that you get a nice flat base, and that's it. If we now close that down, the model's inside the work zone, ready to press the machine icon and start machining.